We are on lesson 11, which is called What are perfect squares, or something to that effect. So we're going to see how perfect squares make some equations easier to solve. So recognizing them in different forms and so forth is what we're doing today. I'm recording right now. I'll link it in the slides just like always. And puzzle piece will be lesson 11. What we do get through today, I think, is enough for you to be able to do the practice tonight. But otherwise, I know my first hour has to finish the lesson tomorrow, but yeah, pretty straightforward lesson. Our next quiz will be the mid-unit quiz. Not sure when exactly how to be it, so we'll estimate it for Thursday. Questions at all? All right, and I did mention Friday that I would make the quiz that you took Friday viewable, and it is. So if you want to correct it and perhaps set it back, you can even do that from home. That's always been the procedure for my class, but some people still are not aware of that. To get the credit back, you, what do you call it? You show all work, and then you give me your new answer. Question. Thank you. You can feeling will do your best now. All right. But yeah, if you want to retake it for full credit, you can do so in tutoring. Tutoring every Tuesday. And there's really not that many Tuesdays left. I did send a message home to all the D and F students in this class. So there's only 5 Tuesdays left for tutoring. There's like 2 Saturday academies left. Really, the only way to get your grade up is to start doing better on those tests. Our tests are 80%, so that's what you have to do. Questions? Okay. So table 3, number 1 on the warm up. So in each of these, we're substituting into A. So what should A be in order to make number 1 true? Okay, so X is what A should be. Right, class? Wouldn't that make it true? So don't overthink it. It says what expression could be substituted for A to make it true. So for the first one, A should be X. And then table 4, what should the A be in number 2? Anytime I tell you guys to plug stuff in, what do I tell you to use? What? Anytime you plug something in, what do I tell you to use? Table 4, can you tell me that? What I tell you to use when you plug something in? No. Okay, so backtrack. Everyone listen to the question I'm asking. And now, since we couldn't answer the first question, now I'm asking a different one. So anytime you plug in a number into an equation, what do I tell you to use? Parentheses. Good. So like if I'm substituting in for number 1, if I'm substituting in X for the A, then it would look something like this. Which isn't that still saying the same thing? So let's see, number 4, let me ask you again. What could I plug in for the A here to make it equal? 3x, right? Because this is what my left side is. If I plug it into A, and remember, you're supposed to use parentheses every time you plug stuff in, it's equal now. So for the second one, A should be 3x, right? Good. Okay. Table 5, what should I put for number 3 for the A? 7x. Here, let me just put that. Anyone disagree with that? Brian? Well, the squared is already here.
Oh,
So just to plug into the A, it would look like that, which isn't that the same as doing 7x times 7x? So yes, that is right. So that's a good question. So plugging into the A, because exponents always tell you to do what to the base number? Multiply that base by itself, however many times the exponent says. So this is still equivalent, even though it looks a little bit different. Table 7, what should go into the A for this one? $25x. Anyone disagree with that? So if I plug in 25x for the A, what that is really telling me to do is multiply 25x by 25x. So if I do that, I get 50x squared. Is that the same as the left side? No. So this one was kind of trickier. So it shouldn't be 25x. Hayden, what do you think it should be? 5x. Let's see if that works. All right, if I plug in 5x, because I bet Hayden was thinking, well, what could I multiply or square to get 25? Now it works. Now I get 25x squared, because 5 squared is 25. So now it's equivalent. So really focusing on, or like remembering when I told you that when you plug stuff in, use parentheses, I feel like that makes it easier to see. Because the squared is only attached to the x, not the 25. Questions on that? Yes? Yes. Or Eamon, you can go too. All right, so questions on the warm-up. I think the main purpose of it was to understand that squaring something is multiplying the base by itself. So moving on. All right, your next task in your groups is to write an equivalent expression in standard form for each of these. So for each of these, they're written as factors. Okay, anytime we go from factor form to standard form, what do we do? Table 8, what do we do to go from factor form to standard form? Right, don't overthink it. What do we do with factors? What are factors? Hold that thought for a second. What do we do with factors? What are factors? They're things we multiply. So if it's in factored form and we need to get to standard form, we just need to multiply. How you multiply kind of depends on the problem. So foiling would work for some of them, not necessarily all of them. Some of them are really just multiplying. So what I will remind you is that if something is squared, you can't necessarily just distribute the exponent. Maybe in the first one you could, but you have to essentially expand it first. So like A, consider writing as 3x and 3x, and then multiplying it out. For problems like B, you need to write it as x plus 1 times x plus 1. And then FOIL, or double distribute, whatever you want to call it. But you can't skip that step. So work out A through F, all you're doing is multiplying them out. That's how you get to standard form, is multiply them out, fully simplify them. Questions on that? Okay, I'll give you 5 minutes. What did you get for A? Or 5 minutes. Okay. Class, do we agree, disagree? It should be a 9x squared.
Oh, yeah.
Alright, because x times x is x squared. But yeah, I would agree. Good job. Table 2. What about B? 7x times 7x is. Alright. Class, agree, disagree? I think it looks good. So yeah, 7 times 7 is 49, x times x is x squared. Table 3, what about C? Okay, so that's a common mistake. All right, that's not gonna be the final answer, so if you put 16x squared, it's wrong. But that is a common mistake. So remember, when it's in this format, how do you multiply them, or what do you call it when we multiply them? We FOIL them. So first, outer, inner, last, or if you don't like that, maybe it's confusing, double distribute. So basically multiply that first x by the second parentheses. So table 3 was x times x, and then x times 4. And that would be the first and the outer that we just multiplied, just so you know. And then multiply or distribute that 4. So then table 3 was 4 times x. And then the last 4 times 4 would be, all right, standard form would be fully simplified. So combine like terms, table 5, what are my like terms? Or sorry, table 4. The 4x's, combine them and we get 8x. So my final answer is x squared plus 8x plus 16. Questions on that? Okay. So D, I kind of gave you a hint for the ones like that look like D through F. You cannot just attach the exponent, like you can't just distribute the exponent. It's not going to be x squared plus 1. All right, you have to expand it first. So table 5, what did you get for D? Final answer.
Oh, that's good.
Okay, so it's not going to be that because we're missing. What you did was the first and the outer terms multiplied. We're still missing, or sorry, you did the first and the last terms multiplied. We're still missing the outer and inner. So, let me kind of move this because it'll let me. So x times x is x squared. What about x times 1, table 5? And then inner terms would be this 1 times this x, we get. And then that last term, the 1 times 1 was 1. All right, combine like terms, table 7, what are my like terms in this one? And combine them, we get, so my final answer is x squared plus 2x plus 1. The only time those middle terms would cancel out, if you remember, are if it's a difference of squares. So if it's a square, like a perfect square, like we're the same exact parentheses, the middle terms shouldn't cancel out. All right. Let's see. Table 8, what did we get for E? X squared, I guess 14. All right, anyone disagree with that? All right, I think it looks good. Don't forget that you have to expand these first. You can't just distribute the exponent of 2. You have to write them as x minus 7 times x minus 7. Once you do your foiling, you do get this as a final answer. All right, the last one is a bit more challenging. Let's do that together. And no, it's really not more challenging, but I know that when it's not a number there, that you guys kind of like freeze up. So first, make sure you expand it, do x plus n times x plus n, and then FOIL or double distribute. What's x times x class? Okay, good. That's my first in FOIL. Outer terms, x times n, what do we get? X times n, what do we get? Good. That's literally it. You don't know what either one is, so most you could do is just write them as together, times each other. And I do like that we put it in alphabetical order, because technically we're supposed to. I would have still accepted xn, but yeah, nx. What about our inner terms? N times x is good. And then our last terms, n times n is n squared. Do we have any like terms? The nx's, what's nx plus nx? It is not. What if I told you it was 1x plus 1x? 2x. Okay. So remember, listen real quick, you're kind of mumbling a lot. When you combine like terms, you don't change the variable at all. You're just adding the coefficients. So both of these coefficients are 1. So 1nx plus 1nx is 2nx. Now, it's kind of cool that they put this one last, because if you looked at E through E, they're all the same, aren't they? Like, they're all like this. They all have an x squared, so they all started with x. But that last number is always your last number squared, right? Everyone see that? So 4 squared, 1 squared, 7 squared, or -7 squared is still a positive. So this kind of models the rest of them. The 2nx, it always ends up being 2 times, listen real quick, 2 times whatever number is in the n position, meaning like the second number in your parentheses. So everyone see that? So here it was 2 times 4, which is 8. 1 times 2, which is 2. -7 times 2, which is -14. So it's following a pattern. So now I'll ask you the next question, which is, why do you think the following expressions can be described as perfect squares? So now they're giving you the expressions in what form? So now they want you to go from standard to factor. That, I'll admit, might be a little more difficult because it's a little more new. But that's why we went through that flow chart on Friday. So for factoring trinomials in standard form, how do we always factor them? What method? To factor them, to get them to look like you can FOIL, you use the diamond method. Now we're going from standard to factor. So A times C on the top, B on the bottom. What would be my A times C in this first example? Okay, good. That'll go on top of your diamond. What's my b in this one?
Six.
What are two numbers that multiply to the top but add to the bottom? Both of them positive. So when I factor it, it looks like this. X plus 3 times x plus 3. Or since they're exactly the same, I could write them as x plus 3 squared, like that. Both are correct. If you factor these other ones, you should notice something. Let's see if you notice it. So now factor these other ones. What's my a times c on the second one? What's my b? Negative 16. What multiplies to the top but adds to the bottom? Notice for these ones, it happens to be the exact same number again. So I could write it like this. Or since the parentheses are exactly the same, I could write it like this. The fraction's a little harder to do, but it is still possible. So something that multiplies to 1/36 but adds to 1/3, I'll just tell you for time purposes, is 1/6. So then this one ends up being x minus 1/6, or plus, sorry, plus, and x plus 1/6. Or write it as a square. So why do you think these are called perfect squares? Because I can write them as a square since the parentheses are exactly the same. So there's ways to recognize it when it's a trinomial and then when it's in factor form. Don't lose your notes, we'll finish it tomorrow, but I do think you have enough now for your homework.